So this is basically day 2 of implicit differentiation. More practice. Nothing new. I mean, the problems might be harder, but the theory is the same. So all we need to do is work some of these together. And I don't know that there's space on this worksheet to do them all on the worksheet. Why don't, just as a start, see how we're going, why don't you try number 1? Yeah, oh, in fact, it says it right there on the worksheet. Work these on notebook paper. Okay, this is not a chance, your opportunity to be a hero and say, look how small my writing is. I can do it on the worksheet. Separate sheet of paper, x cubed plus xy plus y cubed equals 1, and you're finding dy dx. So try that one on your own. I'll hit pause and then we'll come back and look. So there's our calculus first step. In fact, that's our calculus only step, right? The rest is algebra, getting dy dx by itself, solving for dy dx. So keep dy dx on the left side. Anything with dy dx stays on the left. Anything that doesn't have dy dx needs to get out of there and move it over, and that'll get you on your way to solving for dy dx. Again, I moved over the stuff that doesn't have dy dx. Move that stuff out of the way. Factor out dy dx from what's left, and then divide by all of that. So negative 3x squared minus y over x plus 3y squared. And yeah, I don't think there's anything you could do to simplify that. I'm stretching here. You could factor out a negative from the top, but that's about it. That didn't really do much for us, but maybe someone would do that.
So when you take the derivative of all those, would it the derivative of y be dy dx?
It would, but we already did that. Our first step was calculus. We did calculus way up here. This was the derivative step. So that step was take a derivative. Everything after that was algebra. Does that make sense?
Yeah.
You sure?
Yeah.
Okay.
Yes.
Let's skip ahead a little bit to number 4. If y equals xy plus x squared plus 1, find dy dx when x equals negative 1. Before you get started, what rules are you going to be using when you take this derivative? What's one of the rules you see? Product rule. Alright, so try that one. We're doing this one not because the calculus is hard, but because it's got a bonus algebra step thrown in there that you'll need to do. I know that's exciting for you. So take derivative of both sides. Some of you are starting to do the product rule in place, at least for ones that are relatively straightforward. First times derivative of the second plus second times derivative of the first. Again, you don't have to do it in place. You're welcome to write it out. But if you're getting comfortable with the product rule, at least for simpler things, then you can do that. Saves a little bit of time and space. Plus 2x plus 0. At least one of you wrote out plus 0. I'm going to emphasize to yourself that I took the derivative of that. It goes away. See, how much algebra do I want to do at once here? dy dx times 1 minus x equals y plus 2x. That's 2 algebra steps at once. Right, I've moved this guy over and then factored out the dy dx. So dy dx is y plus 2x over 1 minus x. I'm not done yet, because I need to evaluate that when x equals 1. So evaluate when x equals 1. The trouble is, wait, what did I do wrong? Negative 1. Yeah, this was about to go to 0 in the bottom, and I didn't think that happened in this problem. So when x is negative 1. So sure, I can plug that in for x, but then I'm still stuck with a y in there. So let's go back to the original problem up here and say when x is negative 1, y equals negative y plus 1 plus 1. So 2y equals 2 and y equals 1. So there was a little algebra side problem to this to figure out what y is so that we could evaluate this derivative. So 1 plus 2 times negative 1 over 1 minus negative 1. That's a safe stop. So if you're tired of this problem, you can be like, enough of this, I'm done. And that would be fine. But it would equal negative 1/2 if you wanted to keep going.
When you moved over the x dy dx, why is it like 1 minus x? I don't know, I got just 1 negative x in the bottom.
So I should have shown that step more clearly. So when I move it over, I get dy dx minus x dy dx. Then I'll factor out the dy dx. You're waving me off, you got it. Do I need to keep going on this, or are we okay? The trouble is when you factor out dy dx, there's still a 1 left there. I think that may be the problem. So people are like, oh, I factored out and it's gone. Like, well, it's not really gone. You need a 1 there to kind of hold the spot for it.
Wait, how did you know that y would equal 1? Like when you plug in for the y?
I had to go back to the original equation, because if x is negative 1, I need to figure out what y is. So back to the original equation, I plug in negative 1 to figure out what y is. And then I take my x and my y to plug them in my derivative. So they made this problem a little bit harder based on the algebra, not really based on the calculus. All right, let's jump to number 6. 6 gets stars, asterisks, highlights, whatever you need to do to indicate to yourself that in years past this problem has been on the test or one similar to it. What's that?
Never mind.
This year the test is going to be a little bit shortened to fit on a regular day, so I don't know if this particular problem will be cut or not, but in years past this has definitely been one that's on the test. Number 5 is kind of wacky?
Yes.
What is d squared?
That's the second derivative.
Okay.
Oh.
That's the second derivative.
Okay.
So after you find the first derivative, you got to do it again.
And now that x squared at the bottom also means it's the second derivative?
No, that's just the symbol for a second derivative.
Okay.
Let's do 6, and then maybe we'll do 5.
I thought it was funny that we're skipping to 6. Like, oh my gosh, then like 5 is from like maybe 23. It's probably not a big deal then. It's just secondary.
Well, we have time.
No, it's okay. It's just like
Yeah, they're both secondary.
I didn't know what it meant, and also, because it squared the d, and then also squares the x, but
It's not on the same thing? Yeah, you're right. That is a weird...
Why do they do it that way?
Here's one maybe explanation of why they do it that way. So if you want to take the derivative of y, it would look like that. If you wanted to take a second derivative of y, you would do that again. And so you're not really squaring the d. That doesn't really make sense. You're not really squaring the x or the dx. But when you write it like that, that gives you some sense of why you put the 2 on the d and not the y. And in the bottom you put the 2 on the x.
I understand that, except it would be so much easier if they just put parentheses around it and just put a 2. Like a square, like they just square the whole thing.
If they did that?
Yeah.
But that would be the square of the first derivative, not the second derivative, right? So we still have to abide by our math rules.
Why don't they start doing
double.
So what they could have done, and what would have been nicer maybe, you can do the double prime thing.
Yeah.
Yes, that would be acceptable, maybe more clear. Yes, that would be okay. And in fact, I haven't said it much because I wanted to make it real clear that we were using dy dx. But anytime dy dx shows up, you can use y prime. So that makes your life a little easier in terms of writing. I mean, not much, but a little bit. All right, having said all that, let's go back and do number 6. If x cubed plus y cubed equals 8, show that the second derivative is negative 16x over y to the 5th. So there's one nice thing about this problem. It's ugly, it's a second derivative, it's kind of complicated, but they give you the answer. And so sometimes we do that in math classes that are like really hard, like calculus. It's like, hey, here's the answer. Now just try to get there, right? Rather than tell me what the answer is. It's like, I'll tell you the answer. Can you get there? All right, well, there's no magic formula to jump to a second derivative. We're going to have to get the first derivative first and then take another derivative. So first derivative, relatively easy, I think. 3x squared plus 3y squared dy dx equals 0. That's not too bad. So dy dx equals negative, how many algebra steps are you going to let me do at once here? Do all of them? I'll do all of them if you'll tell me what the answer is.
Negative 16x over y.
Thank you. I want to know what the first derivative is, though.
Negative 3x.
So you didn't want to do all of the steps at once. Negative 3x squared over 3y squared, which reduces to negative x squared over y squared. And if we were stopping at the first derivative, it would be fine to stop there. But since we're moving forward, it's probably best to simplify as much as we can so that we don't have more work later on. So now I need to take the derivative of this guy. Because this is my first derivative, now I need a second derivative. So I need to take the derivative of everybody again.
Wait. Nah. Like, just do one.
So first derivative is negative x squared over y squared.
There you go.
But I can't stop there because it tells me to find the second derivative.
No, you don't. Why you put the brackets around the whole thing?
Because I have to take the derivative of both sides. So that the left-hand side becomes, here's your favorite symbol,
Oh my god.
there's the second derivative.
That's so funny.
If you don't like it, you can replace it with y double prime, that's fine. That's the same thing. Mark, what you got?
You're taking the derivative of that that, you can just leave out the part with the threes, right?
Yeah.
Yeah, I'm not gonna. Yeah, I should maybe this is what you meant. Don't.
That's what I'm talking about.
Okay.
Stuck that in the middle.
Yeah, I don't want to take the derivative of this when I'm also going to take the derivative of that. That's because that should be the same thing. Fair point. So that's why Andrew was like, write this first.
Yes.
Okay.
That's why I said no.
So now we need to take the derivative of just this. So the left is the second derivative, y double prime, no problem. What are we going to have to do on the right? The quotient rule. So I'll let the top be f and the bottom be g. F prime would be negative 2x. What's g prime going to be? Two y dy dx. Quotient rule. GF has to come first. So GF prime would be negative 2xy squared minus the other way around, although be careful because we're going to have a minus sign in there. Negative x squared times 2y dy dx all over g squared. There is some good news. Our calculus is done. And if it didn't tell me what to show that it equaled, that would be a safe stop. Because we got the second derivative equals something, and yeah, we have a dy dx in there, but we told them what dy dx is, so that's fine. It's not a safe stop because the direction specifically said, show that the second derivative equals this. And we are not there yet.
You're allowed to skip algebra steps, so can't you just say that why?
You can't skip algebra steps when it says show. Otherwise, why don't you just jump all the way to the end and be like, hey,
No,
here's...
because it's not algebra until, or it's, yeah, you did all the calculus.
Okay, I hear you. You can skip algebra steps, but there's a whole lot of algebra steps between this and this, right? Like, I'm not buying that you look at that and you're like, oh yeah, algebra, it's fine. Trust me.
No, I get it.
Like, no, I don't trust you. Sorry.
Think about it for a second.
It's not his fault, you know. He gets it.
He gets it. It's not my problem for not being able to see it as quickly as Andrew can see it.
Yeah, we get it.
Let's clean it up a little bit. See what we can do here. Minus minus becomes a plus. 2x squared y dy dx. Like my answer that I want doesn't have dy dx in it. So I think in place of dy dx, I'm going to put negative x squared over y squared. I have an expression for dy dx, and I don't want dy dx. I'd rather that expression be in there. Negative x squared over y squared. All over y to the fourth. Let's see, negative 2xy squared minus 2x to the fourth over y. Trying to simplify that last term there. Over y to the fourth. We okay with that? I mean, you people have told me you can skip all the way to the end, so you should be fine with that.
Yeah, I mean, if you think about it, one of the y's is going to go to the bottom, and then the top's just going to equal 16x. In my opinion, it's done there.
Well, we are getting close, and we do need to keep looking at what we're headed for. Like, we're not working this blindly. Like, we are aiming for something. We know what we're supposed to get to. So we are aiming for this. And so you're right. I do need another y in the bottom. So I think now is as good a time as any to multiply the top and the bottom by y. For two reasons. One reason is the reason Andrew pointed out. Now I'm going to get y to the fifth in the bottom, and then, hey, at least my denominator matches, right? I've got to be getting close.
Can you do that? Can you just like move there's like a denominator y already up there? Can you just move that down?
And I get a bonus here. These y's will cancel. So now I've got negative 2xy cubed minus 2x to the fourth.
Why do you think y that's in the denominator that's in like the top?
Yeah, so you have like a fraction on top.
Okay, you just move that y down.
You
This
just move it
y?
down.
Yeah.
Move it down. I can't do that because it's not
Oh,
it's not in that one.
Well, then take it out of there.
I could do that. I can make this y cubed over y, this one, and then move it down, and then I'd have a y cubed right there.
Oh.
It's a different way to get to the same spot. It is a lot. Okay, I've got y to the fifth in the bottom. That's good.
Wait, can you stop for a second? Yeah, because
Rewrite that. That's what I'm aiming for. It's like, how in the world? Just as an effort to clean up, what could I factor out of the negative 2x? And that would leave y cubed plus x cubed. All over y to the fifth. We are super close and you don't see it, and this is why number 6 is so frustrating. Look back at the very, very first thing that number 6 tells you.
The second
Oh.
Why are we owing for those that didn't owe? X cubed plus y cubed equals 8. That was the very first thing they told you, and you already forgot it.
That's what I was
oh my
thinking.
god.
That was an equal sign? We knew that.
I already had that in my head.
I knew that. Why did I need to show all that work? Yes, that's a tricky one. It's a tricky one because of the algebra more so than the calculus. Although the calculus was tricky too because it was two derivatives, which included a quotient rule.
That feels like a magic trick.
What's the point of
And
saying
now I'd like to
stuff?
draw
And-
your attention back to the very first
I don't
question I
understand.
asked.
Last year you're
Is
always
this
like,
your
you're always
comment?
like, what? Yeah, last year.
He had me for pre-cal last year, so it's okay.
We were
Like we missed one day. What are you talking about last year?
we didn't get to say so I had to simplify everything. This year we get it, and every single time you're just like, no, yeah, that is a safe stop, but we have to keep going.
Oh my god.
Like we don't get to use it.
We don't.
We have some bitterness.
Yeah.
That's a fair criticism. Yeah, you don't get to use the safe stop.
Ever.
If it's a free response, you get to use it. If it's multiple choice, you got to clean it up. And if it specifically says show this, well then you got to show that. You can't just be like, it happens, magic.
On the test, all the
I
ones
know.
that are safe stops.
You're on to me. Yes, I guilty. Busted.
Algebra calling my name right now.
College algebra.
No, don't do that. Don't do that.
ACT test, free response anyway.
Statistics can also get me college. So,
It's gonna be on the test.
Yes. Yes.
Is it going to be a free response?
Yes, it would. Yes, it would have to be. Well, yes, it'll be a free
What are you
response.
gonna put as a multiple choice? Like, tell
I
me.
don't know.
I
I guess
wouldn't think
that's-
you're gonna
Circle the
what are you gonna
steps.
put? You gotta circle the answer and give you.
So if you just said.
No, I mean, she could. The question is, I could say find y double prime and not give you the answer.
Yeah, that's what I meant.
And if it was on multiple choice, I could make that one of the answer choices. Yeah. But making it free response and giving you the answer is better than making it multiple choice and not giving you the answer. I think.
Yeah, which is the work.
Is there like partial credit? Like if we get.
Oh, absolutely there's partial credit. It's like a 6-point problem, and you get 2 points for the first derivative, probably 2 more points for getting to the second derivative here,
Number 6 should just be the whole.
and then 2 more points for getting the algebra right.
That tests like everything, like.
It does. I mean, you really don't want a 1-question test, but first derivative, second derivative, chain rule, quotient rule, algebra,
That sounds like the whole test.
it's got it all. You want a 1-question test?
No.
Yes.
Yeah,
like
no,
the
I think
whole
that's-
class.
No, if it like,
Yeah.
make like the very first derivative like worth 70 points, and then the rest like worth 5.
So 70 points for that, and then 20 points for the second derivative, and then 10 points for all the messy algebra after that. And call it a day. Yeah.
And we get partial credit.
And you get partial credit. That would take forever to grade, because if somebody messed this up, then I have to go check to see if this is right, and check this is right, and follow their mistake all the way through.
That's how like English teachers grade essays.
We're trying to make
Like-
this easier for you.
I so appreciate that.